Okay, right. So now let's solve this problem, right? Now this is actually related with dimensional analysis, right? So now it says that the critical depth YCR, that is the critical depth, right, in a V-shaped channel depends upon the discharge Q and some other parameters as acceleration due to gravity and vertex angle theta, right? Now that's the problem, right? The critical depth Y critical in a V-shaped channel, right, depends upon the discharge Q, right, and some other parameters as acceleration due to gravity and the vertex angle, right. So now here there are two questions that they are asking. So they ask how vertex angle theta is made. In other words, how vertex angle theta is, you can say, measured, right? How that angle is measured, right? And derive an equation for y. That means we have to derive an equation for the critical depth. So let's see how to do that, right? So now here there are four basic parameters, right? That's right. Before that, we have to go to the first question. What is the first question? How the angle is made, right? So the answer is very simple, right? So that is actually the angle theta is made by the two side walls of the channel, right? The answer is that angle theta is made, right, is made with the two side walls of the channel, right? Okay, fine. Now next part, derive an equation, right, by using the knowledge in dimensional analysis, right? So now let's first write the basic parameters. So let's put serial number 1, serial number 2, 3 and 4. The first one, critical depth, okay, and let's write the symbol, right, symbol and the dimensions, right, okay. So critical depth, discharge, what is the symbol? Q. Critical depth is YCR, and acceleration due to gravity, acceleration due to gravity, let's say that is G, and vertex angle, okay, that is theta. Vertex angle is theta, right? Okay. So what is the dimension of critical depth? It's a length, right? So capital L. Discharge is a flow rate, meter cubes per second, right, in units. So it will be meter cube, L cube T minus 1. Okay, is that clear? The L cube T minus 1. And G, we know the units ms minus 2. So then dimensions will be L T minus 2, right? So now if you are going to consider the vertex angle, like dimensionless, no dimensions, right? So then no dimensions means m to the power 0, L to the power 0, T to the power 0, right? So what is MLT? MLT are the basic dimensions for mass, length and time, right? So now, how many parameters are there? How many parameters that we have in the problem? See, parameter 1, 2, 3, 4. So that means n equals 4. Okay. Then now how many basic dimensions are used in the problem? Right now, be very careful. We have three basic dimensions. That is okay, mass, length and time. But among those three basic dimensions, right? So how many basic dimensions are used in the problem? So the answer is 2. See, L is used and T is used. See, even though M is there, M is not used. So used basic dimensions, right, or the basic dimensions that are used, so that is M. So M equals 2, right? So then now there's a special equation, right, that is given by n minus m, right? There is a special equation that is n minus m. So what is n? 4. M2, 4 minus 2, the answer is 2. Actually, this equation gives the number of dimensionless, don't go after spellings, okay? I want to be very quick. The number of dimensionless parameters. or quantities, right? So n minus m gives the number of dimensionless parameters. Okay, fine. So that is 2. Now be very careful that in this problem that we already know that if I'm going to consider this guy vertex angle theta, it is dimensionless because it has no dimensions, right? We already know that, but this equation tells that we have two dimensionless quantities, right? So one is known. So what will be the other one? Shall I erase the problem here? So what is the other dimensionless quantity? So let's say that is phi 2, right? That is phi 2. So now we say there is a special way of solving that. So now phi 2 we are going to write by using other three. Now see, if you are going to consider these 4 parameters, one parameter is there that has no dimensions, right? And we have 3 parameters that are having dimensions, right? So we are going to find the other remaining dimensionless quantity by using